To the UEFI Plugfest Taipei 2018. This is hosted by AMI. If you have any question, please go to the second floor of the event center. To begin with today's training, I would like to invite Dong Wei, the president of UEFI Forum, to introduce the state of UEFI. Let's welcome Dong.
Welcome. I'm Dong Wei. Many of you probably know me. I'm actually the vice president, but the chief executive of the UEFI Forum. I'm here to talk about the State of the Union for the UEFI Forum today, to introduce you to the development that we have been doing over the last 6 months. All right, so we have done some of the event reviews first. So this event is actually made possible by the number of sponsors we have. Certainly AMI is the host of the event. We thank them very much to help us provide the venue and the logistics support. And these are the sponsors of the event. So we thank them: AMI, Intel, ARM, Lenovo, Inside, and Phoenix. Of course, UEFI Forum also provides the support. There are a number of events that are open to the audience here, all the members. So tomorrow from 9:30 to 11:30, ARM and Lenovo are going to have a roundtable event. So you're all welcome to join if you're interested in the ARM ecosystem. And basically what we are going to do is we're going to talk about some of the developments in the cloud perspective and how the UEFI standard is helping the deployment of the ARM-based servers. We also have Lenovo providing some of the introduction to the firmware SIG. We're also going to have some sort of roundtable discussions afterwards, so you're all welcome to join. And then we also have what's called the office hours. So we have all the speakers for this morning and tomorrow afternoon, right? So we have this afternoon from 3:30 to 4, and also on Thursday from 3:30 to 4. You're all welcome to talk to the speakers that are presenting either today or tomorrow. All these two events are happening here in this room, so just check back in. There is also a survey. After the event, you should go to this link and give us your feedback. In the past, I think we have been having the Plugfest for the last 11 years. I think the very first one was in 2007. So we have made changes based on your feedback. So your feedback is very valuable to how we organize the Plugfest moving forward. Let me talk about the UEFI Forum a little bit. I think many of you are very familiar now. How many of you are the first-time attendees? Oh, actually there are quite a few. Very good. So we are able to attract new attendees. So that's why I'm going to talk a little bit about the organization of the UEFI Forum. So as you can see, we have 13 promoters who basically forms the board of directors. The BOD basically provides the leadership in the direction or the strategy of how this technology is moving forward. And then we have a number of working groups. The Industry Communication Working Group is responsible for setting up events like this and promote the UEFI technologies across the world in this market. The UEFI Specification Working Group is responsible for defining the UEFI standards. So there is a UEFI specification, right? So that working group is responsible for the content of that specification. And underneath there are a number of sub-teams. Basically, they are responsible for specific topics. The experts in those areas are forming up a small team to basically go through the initial creation of the content of some sort of engineering change requests. And then, when the small group is ready, they can present to the larger working group, and then going through that process, we can make sure the content is mature enough to be included in the specifications. So as you can see, security, configuration, networking, shell, and there was an ARM binding when we initially started the cross-architecture design. Another working group is Platform Initialization Working Group. This is the working group that is responsible for the PI specification. There's a set of specifications that's called Platform Initialization. So that working group is responsible for the particular specification that I talked about. Security, of course, is also very important, so there is a sub-team on that. Test working group, I'm actually chairing that. This is the group that owns the creation of the SCT for the past 12 years. Well, actually before that there was an EFI SCT as well. But I'm going to talk about how we are handling the SCTs moving forward. ACPI Specification Working Group is the working group that is responsible for the content in the ACPI specification. So I think in 2013, we have absorbed the ACPI spec into the UEFI Forum. So the forum is now responsible for the content of ACPI as well. And there are a couple of sub-teams there. One related to the MV, the non-volatile memory handling, and then there is recently a very hot topic about the heterogeneous memory attributes. So that has been formed to handle the kind of devices like FPGA accelerators and such. There is also a UEFI security response team. So as you probably have seen in the introduction video, security is now very important. A lot of researchers, as well as some of the bad guys, are trying to attack, and firmware is the area that if you are able to take hold of the system, then you can probably break the system, so it will turn the system into no use. So we formed this security response team to help address a lot of the vulnerabilities in the implementation of the firmware. So overall, we have about 348 members now, so it's actually a pretty large standard body if you compare to many of the other organizations. And this is the link that we just played the video. This is the link to that video. So if you want to check that video again, especially for the first-time attendees, this one actually explains about the Plugfest very well, what it is. And in terms of the specifications, here is a list of the versions of each of the specifications. You can go to the uefi.org website to check out, download, and do whatever you want to do with it. So these are the current versions. We are, of course, working on the next releases as well. So as I alluded to earlier, so we are changing course on how we handle this SCT. SCT is the self-certifying test suite that we have developed over the last however many years. So the latest official release in terms of how UEFI Forum put onto the website was version 2.6a. So 2.6a was the specification version, and the SCT that was released publicly, officially, was for that particular specifications. But based on a lot of the feedback coming from the community, we as a group of the board of directors decided that we want to transfer this SCT code base to the open source. Thank you. So they're going to be available, they are actually already available at the Tiano Core website. So it's going to be following the same type of licenses that governs the EDK2 development. So the board of directors earlier approved the transfer of the code. And then we have 6 active members in the UEFI community who contributed the UEFI SCT code in the past, and they have to all approve the transfer. So that actually already happened. So the 6 companies were ARM, Biosoft, Dell, HPE, Intel, and Phoenix. So I would like to thank them for the contributions and help approve the transfer to the open source community. So from now on, the SCT development will be under the open source model with quarterly releases. And the initial maintainers, one of them are actually in the room, Eric Jing from Intel. The other one, Supris Venkatesh from ARM, who actually works for me. So we have two of the maintainers initially. So this is a merit-based system. So over time, if community members contribute more, who would be qualified to be a maintainer, we can certainly go through that process. So it is the same process as we have for EDK2, which makes a lot of sense, right? Because tests and code development, we will have them in one place for everyone. So the UTWG, the test working group's role is going to change from designing the test suites to recommending which releases of the SCT that will be matching which specification versions. So we're going to be doing the recommendation, but the true development of the SCT is going to be in the open source community. And the GitHub address is already there. So if you check that GitHub address, you can actually find that there are already new code that are being contributed from Intel and others for the 2.7 version of the UEFI. So firmware market trends. I think the video already alluded to one of the aspects. This is about the security. So the UEFI specification is the only current system firmware plan with security features specified. I think it was already talked about in the video. We designed the secure boot mechanism as part of the boot technology. It's not patched in, it was designed into the system. And if properly implemented, the security specifications established by the UEFI Forum can help everyone in the ecosystem. So try to implement the secure boot mechanism, not only in the firmware, but also in the operating systems as well. I think the security is important from the root of trust all the way to the applications, right? So you cannot just do one part of it. Many of the articles you have seen lately about vulnerabilities in the UEFI implementations, they don't follow these kind of practices, and that's why you have the problems. So please do these implementations. And updates are very important. So we have seen earlier in the year about the Spectre meltdown type of vulnerabilities, and there is a strong desire nowadays to update the firmware as we find these vulnerabilities, right? So update capsule in the UEFI specification is a mechanism that makes life a lot easier for the users to update the firmware when we have these kind of problems surfaced. So the forum is committed to strengthen the security ecosystem by making sure all the resources about the firmware security are available to the developers, helping OEMs, helping ODMs, helping everybody. So there is an email address that you can use to report any of the security issues or vulnerabilities to us, so that the forum can make sure the specifications handle these issues right, and then we also work with the EDK2 community to make sure the implementation also address the issues. So the BIOS vendors would work with us as well. So firmware is virtually in everything. So it's not just the system ROM that contains the firmware, right? All the devices have firmware. If you talk about the growing opportunities, a lot of IoT devices are going to go out there. I think ARM has this vision of having a trillion devices in the world, right, by 2035, I think. So in any case, there are going to be a lot of devices, and here the prediction is that we're having 28 billion devices by 2021. So the ramp up is actually very quick. And also the AI is a very hot topic these days, and the prediction is the AI software revenue will grow from 5.2 billion to 105.8 billion by 2025. So all these devices are going to have firmware, even though, you know, when we talk about AI, right, people don't think about firmware much, but without firmware, you won't have AI either. So, let's have an outlook in 2019, next year. So security will continue as the focus for the UEFI Forum, because you're going to be seeing a lot of reports from the researchers and maybe even the bad guys. Also, Black Hat and all these other conferences, right? There's going to be a lot of reports about implementation issues. So as the community, we're continuing going to be focusing on the security side. And of course, we are going to broaden the architecture support. Right now we already, I think EFI started from the Itanium processor, right? But then it went over to i32, x64, ARch32, ARch64, and I think we also have the RISC-V architecture supporting there as well. So the architecture supports are going to be broadened over time. And then the roadmap, as we incorporate all these updates, are going to be needed by the industry. So the work is going to continue. And also, we have already decided on the venue and dates for the next Plugfest. So you can write down the dates and make the plan accordingly. I think most of the time people want to know the travel plans and so on. So it's going to be in the second week of April, and it's going to be in Bellevue, Washington, near the Microsoft campus. Any questions? If not, I declare the open of the Plugfest.
Thank you for the introduction, Dong. And now let's welcome Glenn Pan from Phoenix for our next presentation: increasing risk to UEFI firmware due to growing attack surfaces. Let's welcome Glenn.
Thank you. I'm Glenn Plant from Phoenix Technologies, and today I'll be talking about increasing risks to UEFI firmware due to growing attack surfaces. Everyone can hear me, right? This is a quick agenda of what I'll be talking about. Firmware as a target, spec extensions that provide new attack surfaces, OEM features that add even more attack surfaces, examples of risky implementation, mitigation recommendations, suggestions for the working groups, and then I'll open the floor to questions at the end. Firmware as a target. As OSs and apps become more hardened, bad actors move into the firmware. If firmware is compromised, nothing that runs later is safe. Malware can spoof an OS, virtual machines, antivirus, anything that runs later than the firmware. Malware could be persistent and run boot after boot, and wiping the system and reinstalling the software may not clear the malware. These are things that everyone in the room has been talking about for years and years, but it's important to note that this is still an ongoing problem. UEFI features add more attack surface. In the past several years, the UEFI Forum has been adding network specifications, support in the specification. Basically, every network protocol that you can think of has been added, and users have added things like SNMP, SMTP, and others. Network connectivity can allow for exploits that don't require physical access to the system. This seems obvious, but for a long time, we kind of decided that if you don't clip onto the chip, you really can't attack the firmware. As soon as you have pre-boot networking, then it opens up the firmware to networked attacks. So it's a little bit more serious. Some have added NTFS file system support to this firmware, which would allow for pre-boot reading from and writing to the Windows operating system. So that would be before exit boot services, and so it would be invisible to the OS end user. So this is an example of a pre-boot network stack that again runs before exit boot services. So if compromised, it would open the system. And then more examples of, these are implementations that are out in running systems in the world. So a Wi-Fi stack and a Bluetooth stack. So why are these features necessary? You could say that we should just close off the firmware, but while they're not needed to boot the box, they enable useful features like remote management, network boot, failure recovery, and other value-add features. So this is not to say that these features themselves are bad. It's just that a lot of care needs to be taken with the implementations of the features to make sure that they are secure. So what are the risks? Eclipsium delivered Black Hat and DEF CON presentations that displayed some of the dangers of these attack surfaces. The examples were at DEF CON and Black Hat, so the knowledge of them is out in the world now, and bad actors are aware of them. They know that many of the implementations have a lot of open ports, and there's no knowledge of if there was any evaluation done to see if those ports need to be open. And they know that some of these implementations are vulnerable to attack. Remote management. Many server type systems allow for remote management interfaces in the pre-boot environment. This may be via VMC and a private network or other methods. This management interface is particularly dangerous as it allows low-level control of things like loading the firmware, UEFI drivers, OSs, device drivers, and software and firmware configuration, which could be misconfigured for evil or denial of service. Remote management can happen at low power states like S5. So it may be completely invisible to end users and may happen when the system is off. So we lose a bit of detectability if the exploit is done while the user thinks the system is turned off. Again, many ports are open for remote management, and we should evaluate if those ports are actually needed before leaving them open. VMCs are particularly vulnerable Some have been shown to be insecure in running systems. Vulnerabilities may allow persistent, unauthorized remote access to the system. The IPMI protocol has known vulnerabilities in it. VMCs depend on a private air-gapped network for access security. And it's common for them to use older processor designs and older software. Many don't securely boot themselves, and their firmware is rarely updated. And they can be used by malevolent host OS or application to compromise the private management network. That private air-gapped network can actually be compromised from outside. So the assumption that if the network is really locked down is made, it may not be truly invulnerable. These couple of difficult to read links down at the bottom are presentations showing vulnerabilities in the private management networks for VMC. SMTP and NTFS at boot time. Eclipsium showed a motherboard with a UI to send an email in the pre-boot environment and support for NTFS. This feature was added as a IT support feature, and since it runs pre-boot, it can be hijacked to send to attach a file to an email and send it to any email address that you wanted to. Again, this is all pre-boot, so it's without the OS knowing about it, and possibly without the user knowing about it. Here's another customer service example. An OEM provided an interface to download an EFI application, run it, and then upload a file to a different URL. The app could be run without signature checks, bypassing the secure boot chain of trust. The EFI app can upload the results to a customer-provided URL. It can be set to run once or periodically, and either of the URLs was spoofable. So it's possible that it was running without any kind of network encryption because it was vulnerable to a man-in-the-middle attack. Eclipsium was able to spoof the URL so that they could transfer anything they wanted from the firmware. So firmware update. The UEFI Forum have been discussing the need to update firmware more regularly. Dong mentioned firmware update in his State of the UEFI. It's important that OEMs have a good path to getting firmware updates because getting security fixes into the ecosystem as soon as possible is important. We can't depend on end users to download updates themselves if the technical bar to doing so is high. So why don't we lower the technical bar and make it so that we can download them automatically over a network. And so many vendors have added pre-boot applications to get updates. They can go to default URL, or the URLs can be customized in some cases. Many can be updated for, can be customized for check frequency. And they typically exchange some sort of XML containing the update availability data. Again, this is not always encrypted, so it can be vulnerable to man-in-the-middle attacks. And that's kind of what Eclipsium did. They were able to spoof the URLs to make it run any EFI application that they want. EFI shell, I think they did a calculator as well. So the URLs can be spoofed. Any issues with update signature checking can be exploited. Insecure messages can be altered or replaced, directing the downloads to anywhere that they want. And their testing showed that malformed messages could cause firmware hangs or buffer overruns. So the firmware could be just hanged by changing the XML. OEMs have been forced to disable the functionality in many of their SKUs due to the vulnerabilities. Debugging interfaces. Traditionally, firmware debugging was done over a proprietary interface or JTAG, which could be fused or disabled or depopulated in production systems. The proprietary interfaces would have a BOM cost that would be restrictive, and blowing the JTAG fuses at end of manufacturing is standard practice. Newer designs allow firmware debugging over USB. USB ports are, of course, left populated and enabled in end-user systems, so that leaves the firmware configuration as the only gate to that debugging interface. A bunch of Eclipsium's research was predicated on finding end-user systems with USB debugging interfaces left enabled. That allowed them to kind of look behind the curtain and see what was going on in the firmware as they were manipulating things from outside. So those are some of the new features that are opening up new attack surfaces. Here's some mitigations that Phoenix recommends. Make sure your company is following basic security practices in code development. Do targeted code reviews. Don't roll your own if there's a quality and tested implementation available. And see earlier Phoenix Plugfest presentation for more examples of best practices. Some hardware and compiler assisted mitigations. Enable NX data protection, stack cookies, heap corruption detection, address space layout randomization, and be sure to disable USB debugging interfaces in your production system. Also, if you're going to have networking, make sure it's encrypted. So this is kind of a call to action. The UEFI Forum needs to have some serious discussions around how firmware update gets done. Leaving OEMs to their own devices with no direction has resulted in some poor and insecure implementations, which are damaging to the community and UEFI's reputation. So what do we do? Does the forum specify an approach? Do we provide example implementations? Or do we provide white papers that give clear guidance for secure implementation? Phoenix believes that the forum should take the lead in helping the membership get it. Does anyone have questions? Yes. Oh, are we giving out mics for the questions?
You mentioned address space layout randomization in the previous slide.
Yes.
Are you aware of any use of that in UEFI implementations?
Yes. I think we gave a presentation with that in it. That would help prevent someone from knowing exactly where different parts of the firmware are just by scanning.
No, but Tiano Core doesn't implement that at the moment, so I was wondering if you're aware of
Any actual implementations of it? Not that I know of. Does anyone know? I mean, if there's a room with someone, there we go.
So I know that the address randomization is not implemented at this point, but Heap Guard has been implemented since UEFI 2018. It's not something like Static Guard, Heap Guard aren't really designed to be shipped, because if you encounter one of those issues in the wild, it'll just, it's actually worse than the surge, whatever it pulls off. But it is good for testing because you can see if, and combining that with your testing for IO, MMU, and those kind of boundary conditions, we'll see if the device is actually behaving itself in those conditions. Well, I've got the mic I was going to ask. Aside from chipset, which is a tool that we recommend running for looking at known mitigations, like all the things you talk about in publication, chipset will typically detect the method for it. Do you have any other tools that you recommend people run on systems on their way through production?
So, for a lot of the things that we've seen, those are OEM applications that are misbehaving. So it would be difficult to detect those. They're not necessarily UEFI attacks. It's more a poor implementation will open the door.
I have two questions, big questions. First is UEFI is very popular in the standard PC and server, right?
Yes.
But now the world is kind of inverse. Is edge computing, IoT device. So what is the benefit to use UEFI in IoT device, a small or special purpose device? That's question one. And the question two is, you realize Phoenix is a US-based companies. Security kind of requirement varies from country to country, right? So what is the specific requirement from US is involved?
So from the US, different from other countries' security requirements?
Yeah, it's obviously different. EU is a little bit different, and then China is very different.
Yes. Yes. So at least as far as these new features, I wouldn't think that the security requirements should be different from those. A lot of these vulnerabilities are pretty basic. I mean, you can hook up a USB firmware debugger and watch what the firmware is doing, and watch and snoop the network and put in a man-in-the-middle attack. So that seems, defending against something like that seems pretty universal. Encrypt the network, make sure that that USB debugging interface is turned off at I can't see a very good reason to have a USB debugging, firmware debugging interface available in an end-user system. At the very least, if you're building release, like a non-debug binary, that should be shut off in all cases. So debugging that kind of, like debugging at the firmware level should require new firmware, a firmware flag. And then for your other question, I don't know if I can speak to the UEFI So UEFI for IoT devices. Yeah, I'm not sure. Does someone know or so as far as from a security standpoint, I'm not sure.
I asked this question is basically firmware is everywhere, like everybody using their own firmware. I have been promoting UEFI, and from my experience, when you see UEFI is good, number one, number two, and then we can policy to any firmware. The only thing I think it stands out is security features. So I think it's very important if you know about the security, about security
And
across the firmware world.
I think that doing things like this, like the mitigations I talked about, and also figuring out firmware update can only help in that space. Because I would think that even more than in the kind of mainstream consumer space, that space would want good solutions for updating its firmware because you have less of a user interface.
Yeah, I do want to make one note about what you're talking about with the why UEFI on edge devices. It's really more eyes on code. If you have UEFI deployments across the billions of devices that we already have in the traditional compute spaces, then you've already essentially beaten up the code for things like firmware update, for basic booting, and so you have essentially a toolbox that's already used on these other platforms. And what you're doing is just scaling that down to cut out the modules that aren't applicable in an edge situation. So you have a more consistent implementation across different devices. The temptation for a lot of what we used to call embedded devices, not that young, is to, well, it's a different device than my standard computer, so I should just roll my own firmware because I made everything else in my garage. And that just means that you have yet another vector for somebody to infiltrate the system that doesn't have as much exposure, as much research put up against it. So that's kind of one of the things that we talk about with UEFI across a broader set of devices. It's just, you implement the minimum amount of things and you're using the same toolbox to for everything else.
That does go back to the mitigation about don't roll your own.
Yeah, and in most of these cases, you're right, there's, our firmware update had a man-in-the-middle attack. Okay, that's because you rolled your own firmware update and you didn't bother doing things like using certificates. Oops, somebody noticed that.
More questions?